Transforming linear functions. A set of functions whose graph have very basic characteristics in common is a what? Family of functions. So we have these graphs that have some basic characteristics, and all of them form a family. They're all related to each other somehow. That's what we think of when we think of family. We're related to people. Here, these are not related to people. They're related to other functions. Well, all linear functions form a family because all of their graphs have the same basic shape. Yeah, it's shape is what we're going to fill that blank in with. Or graph, we could say, either one. Okay, so same basic shape, same basic graph. In other words, when you're done graphing a linear function, they all have a straight line, don't they? Okay. So if we have a family of functions, there's always what we call the most basic function in that family. It's kind of like the one all the others operate around. Does anybody know what kind of a function we call that? Abby? Mm-hmm. That's the parent function. And that it gets referred to a lot. The parent function, the most basic one. So for linear functions, what is the parent function? F of x equals just x. Yeah, the slope is 1, the y-intercept is 0. It rises and runs at a rate of 1 over 1. It's a positive slope, and it crosses at the origin. So when we have the parent function, you can count on it looking like that all the time, all the time. It goes through the origin, rises from left to right, rises at a rate of 1, runs at a rate of 1. And then the graphs of all other linear functions are transformations of this parent. Writing kind of big today, I guess. The graphs of all other linear functions. All other linear functions. Any other linear function that does not have a slope of positive 1 and a y-intercept of 0 has been transformed from the parent function. So we just talked about before we started these notes what are the types of transformations that are covered in this lesson. One of them was a translation, aka also known as a slide. Yeah, when you think translation, you think about a slide. Every point moves the same distance and direction. So if you move 1 point up 2 units, you move every point on the parent function's line up 2 units. If you take a point and reflect it over something, you reflect every other point from that line, from the parent function, over that same something. Okay, what's a rotation also known as? What's a turn? When you think of a rotation, you think about something turning. So when we have a turn, what happens is the slope changes, but the y-intercept does not. Do you think the y-intercept has to change when you do a slide? Think about it. You're going to slide up or you're going to slide down. Does the y-intercept have to change? Yeah, it does. Does the slope have to change? No, you're just moving it up, a point up, and every other point with it. You're moving them up or you're moving them down. We can also move them left or right, but we don't have to deal with that in Algebra 1 right now. But when we do a rotation, now we're not moving every point up or down, now we're turning it, and so the slope is what's changing, not the y-intercept. And that's really important to keep the difference between those. And then the reflection, what can we say that's also known as? Can you think of a reflection? Flip, yeah. It's flipping over something. A move across a line that produces a mirror image. So oftentimes we talk about a reflection being either over the y-axis, so it reflects over the y-axis, or it reflects over the x-axis. It can reflect otherwise also, but I think we only have to deal with it over an axis. Okay, so linear functions, when they're written in slope-intercept form, so we have a linear function written in slope-intercept form. For a vertical translation, vertical, what's that? Up and down, right? So we'd be going up or we'd be going down. So for a vertical translation, what changes but what does not? What did we just say earlier? The slope changes? No. The slope does not change, right? What did we say does change in a translation up or down? The y-intercept changes, yeah. So if a vertical translation, which is the only type of translation we have to deal with, if a vertical translation is the transformation, you can count on the y-intercept changing, but not the slope. For a rotation, the larger the absolute value of the slope, so think about it, we're turning it. Okay, so we got the parent function. Remember what I said, we got the parent function here, and we're going to rotate it. So that would mean we could maybe, we're going to turn it. Maybe we could do this with it. Make it like that. Or maybe we could turn it so it's going to be more like this. Notice the slope is changing, isn't it? Like we said, the slope will change. Well, let's explore then. How are we going to know if it's going to get steeper or not? The larger the absolute value of the slope, what do you think? Do you think this graph will get steeper or less steep? Steeper. Let's think about why. If the slope of the parent function is 1, and we change the slope, we rotate it, and we change it to 4, let's say. Why would that make it steeper? It's going up 4 for only one unit of run, isn't it? Whereas before it was going up 1, 1, 1, 1. Now it's climbing 4 and only going over 1. It has to get steeper, doesn't it? So the larger the absolute value of the slope, the steeper the graph. You can count on that. And why do we have to talk about the absolute value of it? Because if I say to you, which graph is steeper, 4 or -4, and you just thought to yourself, well, the larger the slope, the steeper the graph, would that mean that the graph of a slope with 4 would be steeper than the graph of one that has a slope of -4? No. They just be going different directions is all right. Positive slope goes up from left to right, negative slope goes down from left to right. They still have the same steepness. So we look at their absolute value. We can't say the larger of the two, because 4 is larger than -4. We have to say the absolute value one. Take the absolute value of both of them, and then compare their steepness. Okay, for a reflection across the y-axis, so the y-axis is our vertical one, so we're reflecting across the y-axis. Let's think about this. What do you think would make it flip over? From here to here or from here to here? Apparently I'm saying the slope is going to do something. What would happen? Let's think about that 4 and that -1. Think about that slope that's 4 and -4. What happened? It got multiplied by -1. That's what flipped it over, so it's going the opposite direction. So instead of rising from left to right, and I'm going to pretend that this one line I drew up here in blue, I'm going to say that this is my one that has a slope of 4x. The -4x one would be this one then. F of x equals -4x. It flipped over the y-axis and it's the same steepness, it just is going the opposite direction. So that multiplying by -1 flipped it across the y-axis. Okay, so let's go to the back side here. And it says our directions are to describe the transformation or transformations from the graph of f of x to the graph of g of x. Okay, now let me tell you, remember, f of x and g of x, what kind of notation is that? Function notation. It's really just function notation. And what f of x is saying is f of x was the original line, the original equation. G of x is the transformation of f of x. We can't call it f of x also, because then we'll think that we have two different lines that are starting out. So g of x becomes the transformation. It's just a new equation that came from f of x, so we use a different letter. So our first one, number 1, f of x equals x. Let's use our graphing calculators right now. So turn on, go to your y equals. If there's anything in your y sub 1, y sub 2, y sub 3, any of those, clear them out. In y sub 1, let's put our f of x equals x. So all we have to do is type x. Okay, y sub 2, let's put our g of x, which is x minus 4. X, subtract 4. Okay, before you do anything else, before you get past me here, what do you think is going to be the transformation here? What do you think is going to happen from f of x to g of x? Okay, which transformation is going to? That's what we're looking for. What transformation or transformations would happen?
Translation.
A translation, maybe? Okay. Because what has changed in those equations? Has the slope changed? No. What's changed? The y-intercept has changed. And in fact, the y-intercept did what? Went from 0 to -4, so that means that point moved down 4, didn't it? And then would every other point on the line have to move with it? Absolutely it would, wouldn't it? Did it get reflected?
No.
Did the slopes change? No, because they both have the same slope, which is 1, right? Okay, press the graph key. Do a zoom 6 just in case somebody's been messing around with your calculator. Do a zoom 6 and it'll take you right to the graph. So are we right? Are those lines parallel?
Yes.
Oh, I wonder why they're parallel.
Because
They have the same slope and different y-intercepts. Isn't that amazing? Okay, so what transformation are we going to say happened?
translation.
Okay, we're going to say it was translated. We're going to change it into verb form. F of x was translated 4 units down. And that's the only transformation that happened, right? It didn't turn, it didn't flip. That's what you're going to look for. Did it slide, turn, flip? Okay. Okay, number 2. Without graphing, what do you think? What do you think should be true? Just look at look at the things we're going to look for. Slope, y-intercept. What happened? Is it translation again? Okay, how are we going to say it? Translated 3 units up. 3 units up. Okay. Is that the only transformation you think? Okay, go to your y equals and go to that y sub 2 one and just replace the -4 with +3 in the y sub 2 one. Just change it to +3. And remember, you should get really used to what the parent function, when you graph these, you should be like, well, that's the parent function, I know. Here's my new one. Here's my g of x. Did it do what we said it did? Okay, and are those lines parallel? Isn't that something? Okay. Okay, how about the next one? F of x this time is not the parent function. It starts at x plus 5, and then the new function is x minus 2. What transformation happened? Did the slope change? That's the first thing you're going to look at. Did the slope change? No. They both still have a slope of 1, right? So if the slope didn't change, there's no rotation going on, there's no reflection going on. The slope has to change for either of those, doesn't it? Okay? So the only thing that could possibly have happened is a translation. You agree with me? Okay, well then let's do that. Let's say it translated, and then we'll figure out how. Translated, what do you think? 7 units down. In other words, the y-intercept was at 5, and it ended up down at -2, so it went down 1, 2, 3, 4, 5, and now it's at the origin, 6, 7 to -2. It translated 7 units down. Okay. Would these lines be parallel?
Yes.
Yes. Again, same slope. Different y-intercepts. Okay, so think you got the translation part down? Yeah? Okay. Number 4. F of x is x. G of x is 4x.
The slope changed.
The slope changed. It's a rotation then. So when we talk about a rotation, we have to talk about 2 things. What did it rotate about? Now it always rotates about the y-intercept. Okay? So it rotated, in other words, it's got only one point stays fixed. And that point that stays fixed is the y-intercept. It's got to turn on some point, right? It doesn't move over, it doesn't do any sliding, so it's got to turn on one point. So we say it rotated about, what's the y-intercept of our function that we're transforming? 0, 0, right? So it rotated about, that's our y-intercept. And we have to talk about the steepness. Did it get steeper or less steep? Because, why? Why is it steeper?
The slope increase.
The slope, the absolute value of 4 is 4, and the larger it gets, remember we went from 1 to 4, it got larger, so it's going to get steeper. So there's only really one transformation that went on, but whenever you talk about a rotation, keep in mind, you always have to talk about 2 things. What point did it turn about? What did it rotate about? And then talk about the steepness. How did the steepness, is the steepness the same? Did it get less steep or did it get steeper? Okay, so what do you think for number 5? A rotation, because the slope changed, didn't it? Okay. Now, how will we know if it reflected, you guys? Because remember, the slope is affected by a reflection also. How will we know if when the slope changes, it isn't also a reflection, maybe, too?
The slope would be the opposite.
It'd have to become the opposite, because remember, for a reflection, it's multiplied by -1. So if it was a positive slope, it has to get negative. It has to change to its opposite. If it was a negative slope, it has to be positive. It has to change to its opposite also. So we're going to first talk about the rotation here, because there is no, they both have a positive slope, so we know there's no reflection that went on. So rotated, we are going to talk in verb form. Rotated about, how did we decide what it rotated about? Where's its turning point? The y-intercept. Don't say the origin, because be careful. Not always is the origin the y-intercept. So is the origin the y-intercept this time though? Yes, it is. So we can say 0, 0, but you have to think this way. It rotates about the y-intercept. And same steepness? Steeper?
You got less.
You got less steep. The absolute value of 1/3 is 1/3. Is 1/3 greater than 1? No, so it is less steep. And we don't say steepless. We say is less steep. Okay. There isn't such a word as steepless. Unless we make it up. Okay. Why don't you try the next one on your own? What transformation or transformations happened for number 6? Was there a translation that went on? How do we know? What changes if there's been a translation?
Slope.
The y-intercept. Did the y-intercept change? No, what do they both have a y-intercept of? 0. Okay, so the y-intercept did not change, so no translation happened. Is there a negative sign in front of either of the slopes? No. So if one of them had a negative sign in front of it and the other one didn't, we would say there would have been a reflection. So there's not been a reflection either, right? And one didn't get multiplied by -1. Okay, and then how about the rotation? Well, the slope changed. So it did rotate. What did it rotate about? 0, 0. Okay, so this time it did rotate about 0, 0. Again, be careful though, it's not always. And is it steeper or less steep? Okay, and here's what we do. We compare the absolute value of the transform line to the absolute value of the slope of the other one. Is the absolute value of 7/3, that's 7/3, right? And the absolute value of 3/5 is 3/5. So is 7/3 greater than 3/5 or less than? Greater than. So because the absolute value of 7, you might want this in your notes so you understand why did we make the decision that it is steeper, because the new slope is greater than the old slope. And we compare their absolute values, of course. Anybody get questions? Were you successful with that one? Awesome. Okay, number 7. Did the y-intercept change? Well, the y-intercept for f of x equals x. What's the y-intercept for that one? 0. What's the y-intercept for g of x equals -x? 0. Did it change? No, no translation then. What did change? The slope changed, and it changed to its opposite. Because the slopes are opposite of each other, what happened? Reflected, yeah, reflected across, which axis did we say we're going to talk about? The y-axis. Okay, and when we talk about a reflection, we get to just talk about what it reflected over. That's all we got to worry about. Okay, how about number 8? A reflection again. Let me give you a little hint. Look at the slopes. And if the slopes are the opposite of each other, there was a reflection. Is -1/2 the opposite of 1/2? Or vice versa? They're opposites of each other. So we would say this one also reflected across the y-axis. And I want you to see that it happen on your graphing calculator, so I want you to go put these in y_1 and y_2. You know how to put in fractions now. So the first one you're going to put in -1/2 x. Remember the x is outside the parentheses. And your second one is +1/2 x. When you're all done, you better have an x on your graph. Do you? Yeah. Now, tell me, even though we're not comparing this to the parent function, tell me something about comparing it to the parent function. Let's compare them to the parent function. Are they steeper or less steep than the parent function? Less steep. Because remember, their slope, their absolute value of their slope is smaller than the slope of the parent function, so they should get, so now I want you to go to y_3 and I want you to stick in the parent function. What's the parent function again? Y = x, so you can put an x in y_3. Press graph, and the parent function will appear for you. Are those other two less steep? They are, aren't they? Are they all crossing in the same place on the y-axis? Yeah. The y-intercept was not reflected. Okay. Okay, now, kind of leading you into number 9. F of x equals 2x minus 1. That's our starting function. It's been transformed, and now we have negative 2x plus 3. So we're going to look at their slopes first. What happened? It was reflected because they're opposite slopes, wasn't it? Okay, so we're going to say reflected across the y-axis. What else changed? The y-intercepts. So what kind of a transformation is that? Translation. So, and translated up or down? Up. It started at negative 1, and it ended up at positive 3, so it went up 4 units, didn't it? Okay. Was there a rotation? Do we need to talk about a rotation, do you think? It did turn, didn't it? But in reality, what ended up happening that made it look like it also turned? A reflection. If it reflects, it was going like this, and it reflects, goes the other way, it's symmetric. There's actually, it's just a mirror image of it. We don't have to talk about it as being a turn. We can just talk about it being a reflection. Okay? But then when we get to number 10, look at number 10. F of x equals negative 1/4 x, and g of x equals x minus 2. Boy, there's all kinds of differences here, aren't there? So look at their slopes. First thing you ask yourself, are their slopes opposites? In other words, negative 1/4 for the opposite of that is positive 1/4, and that's not what it is it, in the other one? Okay, so we can't talk about a reflection. Well, actually, we can. We have to talk about a reflection because of that negative sign. So instead of, what we're going to say is it did really reflect because one is negative and the other one is positive, isn't it? So this one's a positive 1. So we still have to talk about a reflection because of that negative sign. Because not only do we talk about them slopes becoming opposites, but remember what happens when a reflection is when you multiply by negative 1. So what really happened here first was this got multiplied by negative 1 and became a positive 1/4. So we are going to talk about it reflected first. And so because one was positive, the other one was negative, that's automatically a reflection. Automatically a reflection. But then if they're not opposites of each other, not just opposite signs, they're not opposites of each other. Here they're just opposite signs, so that's the reflection. Now we have to talk about what else. There was we're still on the slope. The slopes are not opposites of each other, they're just opposite signs. So that's our reflection, opposite signs. The slopes are different. What else happens when the slopes are different? A rotation. It was rotated about, remember what's it rotated about? The y-intercept. What's the y-intercept of this one? 0, 0. And when we talk about a rotation, we don't only talk about where did it turn across, we also have to talk about did it get steeper or less steep. So it went from absolute value of negative 1/4, which is positive 1/4. Oh, no, we want to start with the other way. We want to go absolute value of 1, question mark, absolute value of negative 1/4. We want to compare those. So it got larger, didn't it? The absolute value got larger. So if it gets larger, what happens? This is greater than. If the slope gets bigger, what happens? Is steeper, and is steeper. One more thing, because the y-intercepts changed too. So, what's the y-intercept of this one? 0. What's the y-intercept of the other one? So what did it do? Translated down 2 units. All kinds of things happen. Okay, are you ready to try writing one on your own? They're going to give us the transformations, and we're going to write the new function g of x. So it starts with f of x equals 3x minus 7. We have to reflect it across the y-axis. What's the only thing we have to do to reflect it? Change the slope to the other sign, right? Okay, so g of x we can say g of x is going to have a negative 3x. So that's the only thing that's taking care of that part, the reflecting. Okay, we just did the reflecting right here. And translate it, so I'm going to change to red here, and translate it 7 units up. So we're not really done yet. We can't even really have this g of x here. Let's cross that out. We can't even really do that yet. We're not done with g of x yet. So all we did was change its slope to a negative because the slope was positive. And now we need to translate it 7 units up. What changes when we translate? The y-intercept. We have to go 7 units up. Where's it at right now in the f of x? Negative 7. So what we really need is we need to take that, it's minus 7, and we have to add 7 to it, don't we? So if we add 7, what ends up happening? That's 0, so we end up with our function, our g of x is equal to just negative 3x. There's our transform function. Okay? Now this is a fun lesson. Trying to keep everything straight. Hopefully we pointed out enough of what do you have to look for to decide what type of transformation happened.